Alright, so you just include the total duration of 72 hours, and we can add the pattern time step according to what we advised. This is 72 hours, and the pattern time step is 6 hours. Okay, so we just input 6 hours. Right, so we set our time options. The next is we can create the time pattern. So select the patterns category in the data browser and click the add button, and then we enter a new pattern. A new pattern will appear, and then we can enter and the pattern dialog box will appear. Then we enter the multiplier values. These are multiplier values suggested for us, so the 4 time steps we are targeting, for example, based on the demand. Alright, so what we need to do now is to just select the pattern from the data. So we select patterns, use data, and then we click add. So the multiplier time, we have to include the multipliers we're given, which is 0.5, 1.3, 1.0, and 1.2. So 0.5, 1.3, 1.0, and 1.2. Right, so these are multipliers we have. Usually we have the time period to run up to 24 hours, but for this case we want it to run have the multipliers for at the 4 specified time step. Okay, so we enter the multipliers, we just click OK to accept this. Okay, so we've set the pattern. Next is, so the multipliers are actually used to modify the demand from its base level in each time period. So since we are making a run of 72 hours, which is 3 days, the pattern will wrap around the start once again after each 24 hours interval. So after each 24 hours interval, it will wrap up and go back to beginning and then run, and then depending on the demand it goes like that. So we now need to assign pattern 1 to the demand pattern property of all of the junctions in our network. We can do that manually, or we can utilize one of the EPANET hydraulic options to avoid having to edit each junction individually. So if you bring up options hydraulics in the property editor, you will see that there is an item called default pattern. So if you bring up options here in is it? No, not here. So this is options. Alright, the hydraulics, so there is option hydraulics in the property. You see that there is an item called default pattern. So setting is to 1 will make the demand pattern at each junction equal pattern. Okay, equal pattern 1, providing no other pattern is assigned to the junction. So once this default pattern is set to 1, the whole pattern, for the 3 days, it's going to be the same pattern. Alright, so it's set to 1 already. So we'll move to the next. Next is running an extended period simulation. So now we have to run a periodic simulation. We are now ready to run an extended periodic simulation. So we just click the run, or we'll click on the run button. So let's see. So it is successful again. So we can visualize some of the results. For example, on each element, we can, for example, start with the tank. We can click on the tank, and then we can visualize what happens there. The tank, you can see report graph. So in the graph, we can select. We can say we want to see, the elevation is good, or pressure variation also, the time series, okay, nodes, and click OK. So you can see the pressure variation in link in node 8. Yeah. Alright, so the same for any other node you want to visualize. You just click on it. Once it's blinking, you can come to the report and then try to see the graph. Okay, you can select elevation, or you can see the pressure variation in the notes. You can see it here. Okay, which is quite good. So the next thing is so we can do for anyone. So select the time series, select head as a parameter, and click OK and the likes. Alright, so next, for running pressure driving simulations analysis, we are now okay. So this is running pressure driving analysis as well. We are now ready to run the pressure driving analysis, hydraulic analysis. We can change the base demand, for example, at node 5 from 200 gallons per minute to 1000. Once again, select project and run. Okay, so node 5, where is node 5? This is node 5. So base demand from 200 to 1000. Alright, so we run again. So warning messages were generated. See status report. Okay, we click. So these are warning messages. Right, negative pressures at this hour, negative pressure. Alright, so let's see what causes this. In the description, what do we have? Okay, use the scroll button to find the demand. Okay, after running, you will receive a negative pressure warnings after the simulation. It's time to run pressure driving analysis because the specified demand cannot be satisfied at that time. So select options, hydraulics from the data browser, and then option hydraulics. Then we'll use the scroll bar to find the demand model property. Okay, so I think options. So options, hydraulics. Alright, so options, hydraulics, then we're looking for the demand model, DDA. Okay, so what it says is demand model property, and switch from demand driving analysis DDA to pressure driving analysis. So we change this from DDA to PDA. Right, so yes, so we can close. Alright, set minimum pressure property to be 0 psi. Minimum pressure property to be 0. Okay, 0 already. Okay, next 0, and required pressure to be 20. And leave the pressure exponent. So required pressure should be 20. And then we leave the pressure exponent at 0.5. Okay, so make sure the status report property is set to yes. Status report property. Okay, status report, we have to set it to yes. Alright, so after that set to yes, then we run again. Alright, so we run, you can see it's successful. Okay, good. Then okay, after running it's successful, so I'll open the status report by selecting report status, and then you'll see the demand reduction, pressure reduction report status. So you can see the details in here of everything. Right, okay, click on node 5 and then select report and graph. Right, so we can click on node 5, we can click reports, then we can have the graph. The graph could be of anything depending on your choice. You can have of course time series, so we can select pressure here. Okay, Okay, so you can see the variation right here. So this is node 5. So this is it. You can see the graph pressure, you can check the various elevation and the likes. This is analyzing water age. Water age can be analyzed as well from the data. You can set it. So we can just select options, water quality, and then as you can see option water quality, you click on the browser, edit browser to edit, and select age for the parameter property in the editor. So we click, okay, so we parameter property, we select age. Alright, so we are done. So we can run the simulation again. Okay, so now that but you have to know that running the simulation within 72 hours is too small for us to detect major changes in the age of the water. So you can repeat the simulation using higher number of hours, like 240, then you can see the clean variation as it is, as the case may be. So, but as it is now, you can just change the timing and then you run again and then see what happens. You can see track the water age, but you will not be able to see very much difference because 72 hours is quite small of a time. So you can do the same thing, chlorine analysis. So you select water quality instead of the age, or from the data browser editor. So in the property editor's parameters field, you have to select chlorine instead of age. So you can do the same in here. So from water quality, in the parameter here, you select chemical. So you specify what kind of chemical is it, right? I think that's about it. There's so much to go through, and we have only touched some of the major parts for the EPANET. So keep practicing again and again this tutorial, and you will get used to the software. It's very easy, freely available. You can always download, share, and follow the tutorial to understand the basics of how to actually run simple analysis in the pipe water distribution networks, as well as understand the pressure variation at the nodes, at the elevation variation at the tanks and sources, so it's a very nice software, and I wish you guys the very best. Enjoy EPANET. Thank you.